So today I am going to film a video on a slightly offbeat topic instead of discussing on our regular nonlinear control class. And for your information, in my next 10 or 11 upcoming classes, I would like to continue this discussion. Now the point is that what is the need of this subject. Even if you are going to stop this video and like fast forward it, I request you to please at least listen to my word for first few 5-10 minutes, and once I jump to the actual technical content, then you may skip or fast forward the video as per your own choices. Now here what I would like to say while this is important. If you take any current days paper, what is the motive of any master's theory course? The master's theory course is supposed to prepare their student for so that they can pursue research in advanced area. Now, if you take any paper of IEEE transaction on automatic control or Automatica or any other standard journal, and if you try to comprehend any paper published there on nonlinear system or nonlinear control, you will find yourself in a great difficulty. Like as if somebody has written that paper in Hebrew and you have to understand that means you have to decode everything from Hebrew, and main difficulty you will face because of this mathematical part, and main difficulty you will face because of you will find to comprehend the mathematical treatment of that paper extremely difficult. Now if you find the mathematical treatment of the paper extremely difficult, how can you proceed further? It is not something like means some magazine you are reading this magazine at your leisure time and try to enjoy it. Even if you cannot figure out the total content, there is no harm. Here, if you cannot understand a single word, that would cause or make the understanding of the total paper you will find it very difficult. Now, in our course, here let me tell you few things that are very clear, and those difficulties we are having here. Like what are the difficulties? Like we are having linear system and non-linear system codes. Simultaneously we have two courses. That is very difficult. Now another problem here is that it is actually we are quite fortunate and also quite unfortunate that many applied mathematicians has made potential contribution in this field of nonlinear control engineering and made this very enriched. Now, if you consider today's today's nonlinear control development, you will find there are two type of tools are being used by the control system theorist. One approach is like I cannot myself claim my knowledge in this particular field is so little that I would like to refrain myself from claiming one particular method or means mathematical tool is stronger and more potent than the other one. So I would like to means give you the basic notion of both of these tools, differential geometry and functional analysis. It is also a point we must not forget that I'm not going to claim that they are completely disjoint, but they are like the two sets where their intersection area is very small. Now, if intersection area is very small, then it would become equally difficult for a teacher to teach his student. Another problem with us, all the people who pursued their BTech degree in electrical engineering, why we will find it extremely difficult, because most of the theories are coming from from classical mechanics, like rotational groups, then other many concepts are there, means I cannot name them here because that will totally means consume the 1 hour time for me to just name all the contributions from mechanical or not mechanical, rather mechanics, classical mechanics. Now, problem of us is that we have forgotten many concepts of engineering mechanics, and that would also create somewhat difficulties in our journey. But we should not means give up. Rather, we should try to endure this journey. And here, I would like to discuss the following tools. Like one is so here I would like to discuss these 6 topics. Obviously, not only Banach space, we will also discuss. I forgot to mention that here we will discuss inner product space also. Now, while discussing all these, one thing we should not forget that now another concept will come in our mind, that from where to start and how much to cover. So here I would like to take an intuitive approach rather than analytical and mathematical rigor. So you can at least relate it with your daily example, and then you can means further means if you find the topic interesting, you can learn about that topic by your own effort. Now, while, while if you consider all these, among them, I find that the topic of vector space is easy to start. Why vector space is easier to start for us? Because during our childhood, most of us used to watch mythological series like either Ramayana or Mahabharata. So, in those mythological series, we used to watch how means ancient kings used to shoot arrows, right? Now, whenever I talk about a vector, what impression comes in your mind? Like, what do you mean by a vector? Most of the people understand vector like an arrow, and they are just looking for a convenient target so that they can shoot the arrow or aim the arrow at that target. However, vector, some people who are interested in mathematics and took their linear algebra course seriously during their undergraduate level, they may find a different description of vector. Now, these two, if I ask you that which one is vector, undoubtedly both of them are bona fide vector. But how to means define them in a manner so that we can find a logical agreement, or means logically find it agreeable that we can by means of vector there is no harm, we can consider an arrow as well as an n-dimensional tuple. So, in your high school, what we encountered that a very rigorous definition of why such and such an object is a vector. If you notice, you will find, or if you just relax and think, you will find that while mentioning vector, we usually do not speak that a particular example for a directed arrow is a vector for these reasons, right? Now, this is quite different from saying like 1 is an integer. The way we claim 1 is an integer and the way I am trying to claim that this pointed arrow is a vector is quite different. Why? Because the integer refers to a set, while the vector is at least at its first appearance, it's not referring to a set. Even if we disregard the aspect that vector means those like mosquitoes and flies that are carrying the germs or disease from one place to another place or from one person to another person. If we completely disregard that aspect, still there are at least two acceptable notation of vector is possible. One is that pointed arrow, another one is n-dimensional tuple. Now, this vector makes sense only if we specify itself that both of them are obeying certain rule, and those rules are equally applicable to the pointed arrow and also to the n-dimensional tuple. Now, in order to do that, what we can do, we can define a binary operation. Okay, one thing I would like to mention that you are not obliged to means watch this video or listen to my rant. If you find yourself that you are confident with vector space, you can skip this. What do we mean by the binary operation? Binary operation means it will take two operands and it operates on them and produce the result. Now, like now addition of vector we can define for two elements. Now these what can I say? This requires us to specify that the whole set, like where this addition occurs, all the vectors should like obey this rule of addition or this binary operation, like whether it is a pointed arrow or it is an n-dimensional tuple, they should agreeably means you should find in both the cases the laws are applicable. Now it is like you may ask me that I am intentionally making the simple thing complicated, but like here you too also admit that vector is a concept that can be well defined only if we specify where it belongs and how it behaves with respect to the defined operations, like whether you are considering the pointed arrow or the tuple. In short, in a single line, a self-contradictory statement is like, means not self-contradictory, apparently self-contradictory statement is that vector is an element of a vector space is the right way or the only way to defining a vector. Now, I think I have discussed so many things, and you people are means trying to disregard all this ranting just by saying that mathematicians are laconic. So, for your understanding, let me take one example. Let us take differential equation. Now, those who have taken some course on differential equation in their undergraduate level must have agreed that we can represent the solution like xt is equal to right with arbitrary constant c1 and c2. Now we can define that a set X defined as C1 cos t plus c2 sin t such that c1 comma c2 belongs to R. Sorry, yeah, right. So this actually we are defining a set capital X that contains all the solutions obtained by taking all C1, C2. Now we can then naturally induce the operation of addition and scalar multiplication on this particular set capital X, and you must okay, let me do it, then I will tell you the conclusion. Like you can have C1 cos t plus C2 sin t. Just let me check whether it is recording or not. Yeah, it's recording. Plus d1 sin t plus d2 cos t. Sorry. This is d1 cos t plus d2 sin t. So as per our definition, what we will get? We will get it like, if we define it rather this way, and also if alpha is a real number, then alpha c1 cos t plus c2 sin t, we are defining it, is equal to alpha c1 cos t plus alpha c2 sin t, right? This is possible for all alpha belongs to R. Now here one thing is very clear, that the way we have defined the addition and scalar multiplication on this set capital X, which is also, if you understand, what value X can have, like first of all try to understand that cos t and sin t, what value they can have. Their value will always vary from -1 to +1, and c1 c2, you are also picking up c1 c2 from R. So for any point, means any combination of c1 c2 and any arbitrary time t, you are bound to get a single value for this three combination, like c1 c2 and t, and then that would become a member, or rather that would, what you will get? You will get a real number, and that real number is what? That real number is the subset of the real line defined by this. So here the point is that the sum and scalar multiplication of the elements in X again belong to X, like what you are having now. You are taking two elements of X, and then after doing so, what you are getting? You are getting X was a subset of your real line, and after doing that, the way you have defined, let me again tell you, in mathematics there is nothing is constant. Like, it is my way of defining addition. For this symbol I have defined this. It may so happen that I may use this symbol, and in that case this symbol should be interpreted in that way. It is like it is the means addition, and obviously in that case for all these you have to change the symbol like this, and you will get this. But what about the minus? It is not conventional minus, but I have defined my minus in my way. So that is possible. Now, once you have done this, so what you are getting, that the result of addition and scalar multiplication, the way you have defined, they also results elements that are that belong to your original set. So how we can summarize the entire this discussion? We can write that it will need to satisfy a few axioms. Axiom will be obviously based on this addition and scalar multiplication. Now, so the objective of our means now our objective is to setting the axioms of vector space. Now, one question that may haunt you, like in mathematics, why do we always start from setting up axioms and then just try to verify it, that whether certain structure or certain set is obeying that principle or not? Why cannot we content ourselves with individual, like it may be arrow or n tuple, we will start there and then we will find out their similarity. Why it is so? So in order to answer this question, I understand that this becomes a bit more boring and philosophical talk for you, but try to understand, because later on we will use this kind of means. I know you had a basic course on vector space, so that is why even if I rant and make you enough bored, still for vector space you can connect the dots. But for functional analysis, which is totally a new concept to you, you may not be able to connect the dot. So please try to endure this pathetic, boring rant, so that in future you won't face much trouble while you will see application, or rather extensive applications of those tools in your course. Now, again, I would like to become a bit more philosophical and ask you a question. Like a very straightforward question. If I give you like 4 apple and 5 guava, and if I ask you that how many of they are total, then you will be confused. One natural answer will be 9 object, like 9 unit of fruit. You are considering individual as unit. But this answer, try to understand that this answer makes sense only when we accept the assumption that let us count apple as a fruit and let us count guava as a fruit. Had we started with an assumption that apple is a fruit and guava is a green vegetable, then we have had to answer it in a different manner, like we had 4 fruit and 5 green vegetable, in that way. So why I am saying so, to just to make you understand that why in mathematics we always first define some axioms which is not provable, and then we try to means like just find that what are the structures or objects those are means complying with those the requirements set by your axioms, right? Now, just a minute. So that's what I am trying to say here. It is very clear that without means such identification, and if you still are not able to get my point and think that I am doing some kind of joke here, try to understand the situation. If you replace that 5 guava by 5 bunch of grapes or 5 bunch of lychees, what would happen? How to count? So this so what is the actually here we are having this dilemma? It is the mathematical identification to count an apple and the guava. We are, whenever we are talking about apple and guava, we are assigning one number 1, value 1 for them. This question literally means does not make any sense, but we means it is our natural cognitive ability. Whenever we are being asked to find out the total number, we always assign the natural number like one guava 1, 1 apple 1, so total 2. It's like that. But like if you ask a very young boy that what is the total number, who is not so used to it all this, they may find it, means those who are not exposed to algebra, they may find it very difficult. They will start thinking that means what he is trying to ask. Like if we have 2 different fruit, and how someone can saying that it is possible to means save like we are having 9 fruits. They will be they will be dumbstruck. They will not be able to give you answer. Or if you means insist, some intelligent kid may start thinking that which one is more valuable, like either apple or guava, which one is valuable. No, so jokes apart, so what I am trying to say that the other aspect or other side of the story, that if we always make a distinction in counting apple, guava, then grapes or other means objects, so we for daily life we have to invent one set of mathematical means mathematical tool for handling apple problem, one mathematical tool dedicated for guava counting, another for lychee counting, another for grapes counting. We will be means this will be means a kind of intolerable means they will have redundancy, means redundant representation. You will not be able to handle it. So here that this 11 means from this very basic elementary way of counting, what I am trying to say that the abstraction of counting objects without really distinguishing the irrelevant characteristics of those objects will provide us with a universal, although abstract system that is applicable to any countable object. So now the question is that one like while you are counting, then the aspect of apple and guava, that doesn't make much difference. But when you are trying to calculate the cost, then obviously they will make different. So for different problem, you have to figure out the count in different way. You form your mathematics in different manner. So what I am trying to say that this universalization, like universalization means you are considering apple, guava, all belongs to the set fruit. That is kind of universalization. And then you are abstracting it, like you are for all of them you are assigning an abstract number 1 to all of them. This counting that resulted in what the process that is very familiar with to us, that is first the concept of natural numbers come, then what we got, so all this number invention was like need based, or better to say all the notion of this number invention was need based. And simply why I am doing so much or means ranting for so long, because I want to means impart a sense or means a thought process inside you that when we are trying to form axioms of vector space, that axiomization of vector space, what it would bring to us. Very simple answer to this question is that this will help us the universal understanding of linearity, right? Then you may also find it problematic to understand and define linearity. So, linearity, let us try to define that linearity once again. So, in a layman language, we can say that linearity refers to now let us consider an audio amplifier. So what is the purpose of that audio amplifier? It amplifies the input signal with a certain amount of magnitude, and as long as the magnitude does not exceed its saturation limit, the output of the sum of two signals is the sum of respective outputs. Like what I am trying to say, that if it is a linear audio amplifier and then you are using it for your own amplifying your own voice, if someone makes noise near you, then the audio amplifier will also amplify the noise. It will not filter it out. It will apply the proportional noise or some proportional amplification on that noise also. Now another example of that DDT, sometimes we call it differential operator. In our undergrad level book, we used to consider them by P operator. So this one we can write it like, so this DDT, we can consider that this DDT is a linear operator. Now here we are just ignoring this is just a very informal, and we are just disregarding the aspect of scalar multiplication that we are going to consider later. Now here the operation with such a property, we will be able to find them everywhere, like integral operator, difference operator, linear RLC circuit. Now, one thing it is important to note that even if your input and output may have different dimension also, like in case of audio amplifier, your input is an audio signal, output is an audio signal. But if you have linear, like linear DC motor, then the speed of the DC motor is proportional to the voltage you are applying across it. But voltage is an electrical quantity, and your speed is a mechanical quantity. So that can happen. Anyway, so bring to that our original discussion. So why I am telling all these long rant to you, just to make you understand that by the word axiom in the vector space, we do not specify the meaning of addition, but here we are interested to define a rule. So, like if I am a rule maker or law maker, I will define a rule, and if anyone is willing to obey that rule, he or she can take reside in my territory in that way. So before giving the definition of the vector space, another operation, scalar multiplication, let us discuss about it also. Like linear relation not only always preserves the sum, it is always also like it is concerned with that proportional relation. Like if you add two elements like x and x, it will give you 2x. But in order to make it sense, what we need to equip the notion of product, like product of scalar 2 with your vector x, right? Now now we are ready to have the formal definition of vector space. So we can write So let us write the axioms. So what I am trying to make you understand that a vector space is a composite mathematical structure consisting of a set X along with two algebraic equations, namely addition and scalar multiplication, that satisfy the following axioms. For writing axioms, one side I will write the axioms related to addition, in another side we will write the axioms related to scalar multiplication. So the first operation, addition. How to define addition? If we take pair x comma y from x, then their addition will satisfy or you can take x, y, z also, that for all x, y, z belongs to x, x plus y plus z is equal to x plus y plus z. This is called the law of associativity. Then another one, for all x comma y belongs to x, x plus y is equal to y plus x. This is called commutativity. For all obviously here this plus and the conventional way, the way we understand multiplication, these are commutative, but not the subtraction or division, the common way of understanding that. They are not commutative operation, right? Now this one is very important. There exists an unique element 0 belongs to x, such that for every x belongs to x, zero plus x becomes x, right? And there is exist this is called additive identity. There exists another one, that is for all x belongs to x, there exists x dash belongs to x, such that x plus x dash is equal to 0. This is called additive inverse. Now we will see the properties due to scalar multiplication. Now for scalar multiplication, that is x belongs to capital X and that alpha belongs to the field on which this vector space will be formed, that for every x belongs to X and a comma b belongs to F, a plus bx is equal to ax plus bx. For every x comma y belongs to X, a belongs to F such that ax plus y is equal to x plus ay. Now for every x belongs to X, there exists a comma b belongs to F, that such that abx is equal to a of bx. For every x belongs to X, 1x is equal to X. So here are 4 things we have observed, but that multiplicative inverse is not present, only multiplicative identity is present. In this one is our multiplicative identity. So if one set of object X fulfill or comply with these 8 axioms, and then we can say that X forms a vector field over field F, right? X forms a vector field over vector space over field F. So now one thing we must note that addition are different, like here the left side and right side addition are different. This one, that a plus bx, this a plus b is scalar, however this x plus bx, they are the two vector, however the result remains same, like a plus b, two scalar you add and then amplify a vector, and you amplify that vector separately and then add, the result remains same. But in principle they are different. Now this condition 2c, 2a and 2b, they together, like 2a and 2b together referred to as distributive law for right. Now in our next class we'll see a few examples of vector space. For the first class I intentionally make it slow pace and somewhat boring. So if you feel interested, then you please keep on watching the upcoming videos, or otherwise you can learn the topics. Like after this 11 classes, then we need all these topics, and then I would not be able to repeat them once again. So it is up to you that from where or how you will able to learn them.